we're going to continue with 4.5 today, solving polynomial equations. I want you to try number 5 on your own. Okay? Right now on your own, think about all the factors of 24. Our a term happens to be 1, so we don't have to really worry about that right now, but all the possible solutions you could have, and try to find a linear factor that goes into that. Okay? Do your best. One of your strategies as you approach this was the thing you didn't understand yesterday, like the PQ thing. Okay, that's kind of the right process. Okay, if you think about yesterday's lesson and what we referenced on yesterday's lesson, let me actually grab that page real quick. It's in your student journal. It was one of the theorems that we talked about. This guy right here that said, the rational roots theorem, saying that if we have all this big long polynomial, which, by the way, we have, and we want to find the actual answers to that, the rational roots when f of x is 0, which f of x is 0, then those possible solutions have to be a factor of p, or excuse me, a factor of a sub 0, which is our constant, and a factor of our leading coefficient, a sub n, which we call p over q. So in other words, when we're applying what looks really confusing right there, when you're applying that, when you're trying to solve something you can't do anyone try factor by grouping? Okay, good. That's good strategy. If you tried that, great. That would be something I expect you to try. It doesn't work here, but you tried it. Okay? So what I would do using the rational roots theorem is look at my coefficient. I've got a leading coefficient of 1. I've got a constant of 24. That means all of my possible solutions are, well, take all the factors of 24. So 1, 2, 3, 4, 6, keep going, 8, 12, and 24. All the factors of 24 divided by all the factors of 1. Whoa. All those factors of 1. My goodness, that is a lot. Okay. Yeah, we'll get to that. Okay? Hey, guys, yeah, if it was like 48, you would have tons of possible solutions.
Will you ever do that?
You will eventually have to do that if you continue in math. Okay, I'm not going there right now. And then the other thing you have to include is the positive negative. So every one of those has 2 possibilities. Plus, minus. Now, here's what I'll tell you, and I'm hoping you guys, you have to start learning conceptually, not learning pieces as independent values. You've got to see how all this goes together. So, like, the stuff you've learned to help you with this is factoring. That's where your branch, you should be tying this to factoring. And to the graph. You know what a cubic graph looks like. It has to cross the x-axis how many times at least? Okay, what's the end behavior of a cubic? It's down, up. Come on, so these are the things, like, that's still this chapter, right? That was the beginning of this chapter. It was very easy when you did it. Now that you haven't done that, that's where you should start reviewing. Because for those of you that struggle on your exams, usually it's because you learn things in pieces. You're not putting the things together as big concepts. Okay? This is a down-up. It has to cross x at least once. Means it has to have at least one what? One solution. One real solution. 1, 0. Okay? It is a third degree. Meaning it is how many degrees away from a second degree. And why do you like second degrees? Tell your neighbor why you like the x squareds. Okay. Hey, what is beneficial about an x squared equation? Rory? You can factor it easy, and if you can't factor, you can do what? You can at least do the quadratic formula on it all the time. So if you can get it to a quadratic, you can find all possible solutions, whether real or complex. The problem is you have to find a real solution first. And to find the real solution, which is going to be here, it's going to be x plus or minus something. Okay, I know it's x and x squared because that's a 1, but that would end up washing out anyway, whether you knew that or not. Okay, the important thing is you have a first degree times a second degree, which is a cubic. You're looking for one of those real solutions, and we know it has to have a real solution because the end behavior of this graph is down up. Okay, that is bringing everything together. Okay, the new piece is trying to find that solution, which means you have to test all of these things until you find one that works. Now, I'll tell you the easy way to test the number, like positive 1 as a solution. Remember, if positive 1 is a solution, that means this quantity is actually x what? Is it x minus 1 or x plus 1? Okay, that's not resounding enough. If positive 1's an answer, you guys talk to your neighbor. What is it here? Is that x minus 1 or plus 1? Tell your neighbor why. Okay, everyone has a vote. How many say minus 1? How many say plus 1? Okay, not everyone voted, which means you are not taking ownership to an answer. So figure out which one it is and why. Otherwise, you probably miss it later on. Have a reason behind it. Whether it's right or wrong, at least you have a reason. Okay, how many say positive 1? Or plus 1, excuse me. How many say minus 1? The answer is minus 1. Why is it minus 1? Because when x minus 1 equals 0, you get x equals 1, which is your solution. Okay, so let's see if 1 works. I will tell you the easiest way to test 1 is just add the coefficients. When you put 1 in for x, nothing changes. Add 1 minus 5 minus 2 plus 24. Is that 0? No. There's a lot of positives and not many negatives. That is not 0. 1 does not work. Positive 1 is not one that works. Okay? Now, from here on out, when I test them, I'm going to test using synthetic division. For those of you like, you got to be kidding. I hate synthetic division. Okay, well, at least I didn't say you have to test using polynomial long division. Okay? So, synthetic division, I try negative 1. I just crank it in real quick. Negative 1, I have 1, negative 5, negative 2, 24. You guys, by the way, this is the way I write it. It was pointed out to me yesterday by a student that your book writes it like this, and it's just another way of writing it. They write that same thing like this. They put the 1 out there, and they put, what, 1, negative 5, negative 2, 24. Okay? Yeah, and it's up to you how you write it. You'll have other teachers that do it a different way, probably. I learned it like this. That's why I write it like that. Okay? 1, what's this? Negative 4. 1 times negative 4 is negative 4. Negative 6. 1 times negative 6 is negative 6 and 18. Now, some of you are sitting there right now going, yeah, I can do that. I remember that piece of this chapter. That was this chapter. Okay? But you have no idea why we just did that. That's a problem. If you're like, I don't even know why we did that. Okay? There you're not putting the things together. So why did we do that? Matt? Okay, it's determined if x plus 1 is a factor, and we already determined it wasn't, right? By the way we added them up. We had a remainder at the end, correct? Okay, this has a remainder. We've already determined 1 wasn't just by adding the coefficients. Was it faster to just add the coefficients? Yeah. Okay, we just tested positive 1. Now, if we test negative 1, we've got to put negative 1 in here, correct? Okay, and we go through the same process. So, by the way, I would never do that. I would just add the coefficients. But negative 1, we actually have to go through that process. Yeah, so good question. If I'm saying a solution is -1, this would actually be x plus 1, right? So I'm testing the solution of -1 right there. So I actually put the -1 in. Okay? Yeah.
So if all of the answers in the possible solutions are real solutions, what defines them as possible? Are they irrational solutions?
Can we come back to that? Right now you have to have one real solution, right? Okay, because it crosses. So if I don't know, if I don't have any real solution, like there are times like you could have a 4th degree where there aren't any real solutions and they'd all be complex solutions. Okay, but for this one we know we have to have at least one. So we're not. Good news for you is we're not doing this in vain. You're like, oh, well there could be none. That stinks. Well, we know there has to be at least one. Okay, so I try -1. Let's see if it works. What do I get? 1 here, -1, -6, multiply, 6, add, 4, multiply, negative, oh darn. Thought someone said -24. Shoot. Does it work? No, how come? Remainder 20. What do we want this to be? 0. This is how synthetic division ties to what we're doing right now. This is why you learn synthetic division. So when you go back to that lesson where you're like, oh, polynomial long division, bummer, I don't like that. Synthetic division, I like that much more. That's why you learn that. It's the whole point of that lesson. Okay? So we go on. It's bad when you have to get another piece of paper. I'm writing really big. Okay? So what's the next? So -1 didn't work, so this one's done. None of those work. What's the next one I should test? +2. Okay, I like to test my negatives first, even though I tested positive here. Okay, I'm going to test -2. And you guys, the reason I like to test my negatives first when I'm dealing with a positive coefficient. Does everyone understand why? Okay, in this case, it's because, look, when I have a negative, I want some negatives over here. Okay, and when I cube a negative, what do I get? A negative. Okay, so in this type of problem, if you start thinking about it, you're like, well, probably need a negative number. Some of you may not get to that point, but I'm to that point where I'm like, dude, I think I want a negative, so I'm going to test my negative before my positive. Okay, so this gives me, you guys test it on your own. It's so fun to watch you guys work sometimes because some of you are like cranking away. Some of you just stare at the screen and try to do it in your head. And then I can tell exactly when you messed up in your head because your face goes to a weird contorted look. It's pretty awesome. Just saying. I'm just saying I'm not. Oh, hey, did you guys get 0? Yeah, man. Hey, that's great. That means this quantity right here is what? Is x plus 2. That gives us a -2 as a solution. So note why it's x plus 2. What's this? That's 1x squared. Okay, that's why we do that. That's how all that stuff goes together. Okay? So, from that point, I kind of have to flip my paper over here. I've got that. Can I factor this? Yes, in this case we can. It becomes x minus. Okay, now that's just basic factoring. You're like, remember the good old days of just factoring. You're like, oh, I missed that. Okay? All that equals 0. Our solutions are, it's the things that make these equal 0. -2 plus 2 is 0. 3 minus 3 is 0. And 4 minus 4 is 0. Those are my solutions. That's how all that stuff ties together. The good news is, oh, yeah, that is good news. You use brackets. Okay, the good news is I think that's the hardest part of this lesson. Okay? The bad news is, well, let's get to that here real quick. After any questions on that? Matt?
Would there ever be a situation where you have more factors outside of those?
Like another number out here? Is that what you mean?
I mean, like, so not just x plus 2, x minus 3, x minus 4, but say an entirely different sequence of...
You can't if it's a cubic. The most you could have is 3. Right? So, I mean, if it was a 5th degree, you could possibly have 5. Okay? None of these, well, which ones worked? I mean, we could have tested which other ones would have worked up here. If you guys truly understand, this was a solution. -2 worked. +3 would have worked. And +4. None of those others would have worked. So if you would have kept going down the line, you could have found them all that way. It would have took longer, right? But you could have. All right. All of your real solutions are contained up here. You just have to pull them out. So if you, like worst case scenario on your test, you won't finish your test, which means you won't get a grade. Okay? You could test every one of these and say, okay, I tested them all, and the only ones I found were that one, that one, that one. There, I'm good. That would have took forever, though. All right. All right. The bad news is we now have this one. Okay, but you can do it now. So find your pos. Well, I'll let you get as far as you can on it there. Okay, guys, I realize you are not done with it, but I want to make sure that everyone's on the right track. So as you're going through this problem, you should be listing all the possible zeros first. And when you do the possible zeros, you've got to think of all factors of 12. And then all factors of 3. So when I do that, I'm going to go, I mean, there's only 2 factors of 3, but it's not as easy as just putting 1. I will tell you that those are the easiest ones to check because they're whole numbers. Because the next set, you have all your factors of 12 and 3 now. Dude, that's 1/3. You don't want to have to test 1/3. That's 2/3. That's 3/3, which is the same as 1. So we have that one right there. We don't have to test that one twice. This is 4/3. 6/3 is the same as 2, so we don't have to test that one twice. And then 12/3, which is 4. And, oh, sorry. And then you have to go your plus minus in there. So you have to get all your factors down first, and then you guys always start with the smaller numbers, right? I mean, don't test. Don't go, well, you know what? I'm just amazing, so I'm going to start with 12. That's what I do. Okay? Just start with 1 and -1. And then move on to 2 and -2, and so on. Okay? And how many found one that works? Come on, man. Some of my good comedy. It works. Okay, hey, I need everyone's attention back here real quick. Just to make sure, once again, we're all at the same spot. We tested one happened to work. Once again, I mean, test it, we get x. It's -1, right? And notice this is a 4th degree. That means this is the first term is going to be cubed. Okay, so we didn't get the quadratic we want, but we got closer to the quadratic we want. Now, here's the oops. Here's the bad news. When you get a cubic here, and by the way, f of x we made 0. Okay? When you get a cubic here, that means you have to go through this process all over again. That's one. That's the bad news. The good news is you only have to do that if none of your other strategies work.
Oh, so you can try the thing.
So what can we try when we have 4 terms? Try factor by grouping and see if it works.
That's what I meant.
Does this make sense?
Yeah, it kind of makes sense.
That's how I think. Visually. Parentheses.
Try factor by grouping. That's why we learned that in the last lesson. So we're like tying almost the whole chapter together in one little warm-up. Yeah, well, it's 4.5. We go to 4.9. So we got a lot more to tie together. But that's okay.
It's like there's books with 2 stories.
Yeah,
in
then we have the
end of the first one. But then the second one is a sequel. I don't know. I'm just trying to make a metaphor here. Stop. What? Yeah.
The other thing that worries me about the answer is like mine too.
I just get shot.
You get root 12 as one of your answers. I'm like, where's that?
What is root 12? Think of it as decimal. Okay. Hey, factor by grouping. It looks like it's going to work out. Okay, we pull out, need everyone's attention back up here. Pull out x squared. It's 3 plus 1, or 3x plus 1. We pull out negative 12. We get 3x plus 1. That's good because now we have a common factor of, we have the 3x plus 1. So, actually, let's write that first. 3x plus 1. That leaves us remaining x squared minus 12. And then all of that is still being multiplied by x minus 1. Okay? We have now factored that. That's awesome, dude. You can go home. What'd you learn today? Well, I learned how to factor this to that. I don't want to brag, but that's what I did. Okay? What's x equal here? 1. What's x equal here? Negative 1/3. Now, guys, on this one right here, Walsh, quit talking. You get x squared minus 12 equals 0. X squared equals 12. And x equals plus minus root 12, which is plus minus root 4 by root 4 by root 3, which is 2 root 3. Okay? So this is plus minus 2 root 3. Now, in terms of our answer, that's a fine answer for x. That's what x equals. When you're thinking about where it crosses the x-axis, crosses here, and it crosses here, and plus and minus. 2 root 3 has a decimal form. It's an approximation at where it crosses, right? It doesn't cross at a whole number. But it crosses 4 times, which is the most we could have. It also crosses at negative 1/3, which we actually had up here in our list. Okay? Yeah.
Do we have the fraction equivalent of 2 root 3 in our list?
No, because it's irrational. Right? It's not a terminating decimal, so there's no fraction equivalent. Yes?
Outside of like Trig, like where do you use measuring?
You'll use it if you were dealing with anything that has electricity. You would use imaginary numbers. Okay? Any kind of electrical current stuff. All right. We good? Okay. I need you guys to take out your student journal. Hey guys, by the way, just so you know, you really applied almost our entire chapter in our warm-up. Okay, so tying all that together, when you go to study for your test, make a note that, like, if you want, this is 4.5 day 2 on the video lessons. Like, you could rewatch this, and this ties a lot of it together in one spot. Okay, all right. take a look at number 7, please, in your student journal, page 99. Number 7. I do not want to spend a lot of time on these. However, I do want you to go through number 7 and do your best to graph it. And I'll tell you, just go ahead and put your x-axis right here. I want you to go ahead and graph that one. All right, ladies and gentlemen. Hey, first step. Let's go ahead and factor it, right? It'd be nice to know where zeros are so we can plot them, so let's factor it. We can take an x to the second out, and that gives us x squared minus x minus 12. All that equals 0. So we plug in f of x equals 0, then we know where it crosses the x-axis. So from this, we actually know 2 of our zeros are at 0, because it's x squared. Okay, does this piece factor? Yeah, it actually becomes, so we have x squared times x minus 4 and x plus 3. So we have 0, 0. What happens there? It bumps, right? That's a turn. This gives us a 0 of 4 and a 0 of negative 3. So 4, 1, 2, 3, 4. Negative 3, 1, 2, 3. And this has an end behavior of up, up. So it starts up here. It goes through negative 3. It gets to 0 and it bounces. And then goes back up through 4. Now remember, our relative maximum or minimums in this case, that's that one and that one, those are not necessarily accurate. However, when you graph these now, I want you to try to put, try to make your y-intercepts as accurate as you can. Okay? If it works out, you may have to change, you're going to have to change some of the scales on the grids I gave you. Just cross out, like on today's assignment, what's the y-intercept on this? 16, and I only go up to 10. So you're going to have to change that. Okay, I know. Sorry, I tried to give you a grid and I messed it up. All right. Okay, questions? All right, huh? Almost. One last problem while I'm handing out your assignment. It's number 13 on page 100. Number 13. I want you to talk to your neighbor about what you're going to do there. Okay. Hey guys, any ideas here? Troy? Good. So so what you have is you have x plus 5 from that 0. And then you could use the quantity x. Did you say x minus 4 plus root 2? Yeah, you could go through that process. In fact, that's the way the book takes it. They say to go ahead and put in this, x minus 4 plus root 2. Okay? Now, the deal is the complex conjugates theorem, that's this, or the irrational conjugates theorem, that's this. This says, hey, if you have one thing where you have a real plus a radical, then you're automatically going to have another where it's a real minus a radical. And that is kind of confusing if you don't understand why that is. Okay, so what I want to do is I just want to point out kind of a different way to go about this. This is a way you'll see on the book. Well, let me finish this real quick. This is what you would see in the book. They'd have you go through this process. So since you have x minus 4 plus root 2, you're going to have x plus 4 plus root 2. And then you would have to go through the math of multiplying all that out. Okay? Yeah. Oh, yes. Thank you. Yeah. 4 plus root 2. Okay? And it would actually be x minus that. Okay. But I'm not going to go through and do that because I think it takes a little longer. I'd actually like to show you why that works. If I know that x equals this, we can agree that x equals, oops, thank you. If we know that x equals 4 plus root 2, everyone agree there?
Yep.
Okay, and I want to solve for 0. Just get it into I want to get x, so put it all kind of on the same side there. Okay, set it equal to 0. I would end up moving. Actually, I'll let you guys go through it. What do you do? You'll go ahead and do it on your paper there. Okay, how many did that? Move the 4 over. How do you get rid of that radical? Square both sides. Now you put it in like that. You don't square x and then square 16 to get x minus 6 or x plus 16. That's not right. Square it. That all gives you 2. And now what? Trying to get 0 over here. What do we have to do? Subtract 2. Okay. Very good. And then we get x squared minus 8x plus 16, all minus 2. So that became that. Okay. It gives us x squared minus 8x plus 14. That is what goes right here. That's what we're multiplying by. That's why you would end up with 2 different answers. This x squared is actually going to give you 4 plus root 2, but it's also going to give you 4 minus root 2. So if I were to actually factor this piece out, which is not what they're asking us to do, but this chunk right here factors to 4 plus root 2 and 4 minus root 2. Once again, I forgot the minus. That's what that factors to. Okay? Or x, excuse me, I have x plus and x minus there. Okay? You'd still have your x in there. All right, so what I'm trying to do now is I'm trying to write the polynomial, which means I actually have to multiply that out. Off you go, multiplying it out. While you multiply it out, I'm going to hand out the assignment. All right, there we got it. How many got it? Okay, questions? All right, take a look at your assignment. 4.5, practice A. The top part should be easy. It's a lot of factoring. Okay, the puzzle time you did yesterday, when you finish it now, that means you show all your work. You can turn it in for extra credit. Okay, you got to show all your work on it. All right, on all the problems. So the ones that you couldn't do yesterday, the ones on the back that were tough, you were just like trying to deduct what to do. Now you should be able to do it. Okay? Hey guys, for those of you that were looking at this number 13 a minute ago, and the way I had written it, I forgot some parentheses in there. So that's how you could have wrote it using the irrational conjugates theorem. But I think the other way might work a little easier as well. But there it is, just in case.